Hello, this is Mr. Stansbury. I'm going to take you through the notes on exponential equations. At the end of this, you should be able to say, I can solve exponential equations. I'm sure you're asking, what's an exponential equation? Well, an exponential equation is an equation where the exponent is a variable. For example, 3 to the x equals 71. That's an exponential equation because the exponent is the variable. Okay? One way to solve exponential equations is to write both sides of the equation with the same base and then use the fact that if you've got base to the m power equals base to another power, those two things have to equal each other, right? Because the bases are the same, so the m has to equal the n. Okay? For example, we've got solve 2 to the x equals 8. What we want to do is we want to get both of these numbers here to be the same. So right now we have 2 and 8. The easiest way usually to do this is to pick the smaller of the two and see if you can get the other number to have the same base number as the smaller number. So I'm going to leave 2 to the x, and is there a way to write 8 as 2 to some power? 8 times 8 times 8, or sorry, 8 times 8. 2 times 2 times 2 gives us 8. So 2 to the third is going to equal 8. And guess what? Look, if these bases are the same, then we know that x has to equal 3, right? Because 2 to the third would equal 2 to the third. Okay? For b, similar idea, but first we got to get rid of this 6. So since it's 6 times 4 to the x, we're going to want to divide both sides by 6. And then we'll try to get them both into the same base. Okay, so if we take 96 and divide it by 6, we get 16. Okay, so I'm going to try to, we've got base 4 here. I'm going to try to get this 16 into a base 4. So we got 4 to the x equals 16, we know is 4 squared. So we now know that x has to equal 2. Okay? Okay, we got 2 examples left, so let's do a quick comedy break.
There's a song in Dora the Explorer that amazes me, and I wish I had been at the pitch meeting where it was approved. So did you get a chance to work on a song? Oh, yeah. Well, I remember now that you want, yeah, of course. Yeah, we're working on it. Yeah. Why don't you go ahead and sing it for us then? Oh, okay. Well, you want that now? Okay. Okay, here we go. I'm the map, 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 I'm the map! Okay. And which character would be singing this?
Okay. So for C here, we've got 3 to the 2x equals 9 squared. So I'm going to try to get both of these into base 3. So I'm going to leave the 3 to the 2x. And then 9 we know is 3 squared, right? That equals 9. And then we got to raise that to the second power. Okay, so we have 3 to the 2x equals 3 squared squared. Really, that's 3 squared times 3 squared. So that's 2 3's here, 2 3's there. So that's 3 to the 4th. So now that we have the same base here, we know that 2x has to now equal 4. Divide both of these by 2, and we get that x has to be 2. Okay. Same thing with this last one here, 5 to the 4x. We're going to try to get both of these into base 5 if we can. Sometimes you got to change both of them, but in these cases here, we haven't had to change both of them, so it makes it a little bit nicer for us. Anyway, we got 5 to the 4x. We're going to leave that alone because we know that 125 is 5 squared to the x minus 1, right? So 5 to the 4x equals, and when you have a power raised to another power, you multiply these two things together. So think of this as 2 times x and 2 times negative 1. So that's going to be 5 to the 2x minus 2. These are now in the same base, so now we can say that 4x equals 2x minus 2. Let's see, let's subtract 2x from both sides. And we get 2x equals negative 2. Divide both of those by 2, and we know that x has to equal negative 1. Okay? All right. That's all there is for exponential equations. If you have any further questions, please feel free to ask. Thanks.